Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. We are going to continue what we was talking about reflection, okay, last time, okay, and we are going to start talking about refraction today, inshallah. So reflection, as we defined it last time, is the bounce of the wave from a surface. So any bounce of any wave from a surface that's called reflection, even if it was echo, like sound, or reflection of an image, like light, what we are studying in details, or any reflection as we studied before about water waves, okay? So we have to know that there is a law of reflection, and this law of reflection says that angle of incidence equal angle of reflection. If we have an incident ray, okay, now this incident ray, it has an angle of incidence I, okay, with something called normal. What's the normal again? If this is the surface, and this is the perpendicular line to the plane of the surface, like this, okay, 90 degrees with the surface. Whenever we change the direction of the surface, the normal, it's 90 degrees with it, with the surface. That's called normal, okay, and this is the surface. Now, if this is, there is an incident ray, and this incident ray pointed in this direction like this angle is called the angle of incidence, and the light will reflect, okay, to make a same angle in the opposite direction. That's called angle of reflection. They have to be equal to each other, and it reflects in this way, like this, okay? Tamam? Good. So the same thing happens if we are not talking about incident rays. We are talking about what? If we're talking about what? Wavefronts. If this is a wavefront, as you can see, okay, this wavefront reached the surface, okay, with an angle equal I, angle of incidence, which is equal the same as this I between the ray, okay, the incident ray, and the normal. Why is this? Because of trigonometry, okay? And even if the light was perpendicular to the surface, 90 degrees to the surface, okay, and it was along the normal, the angle of incidence is, as you can see, the light reflected the same angle. Here in this situation, angle of incidence and angle of reflection both are equal, what, 0 degrees, because it's the same what with the normal, okay, along the side with what, with the normal. Excuse me, but a lot of questions the students they ask. Okay, tamam. So it doesn't matter how we are talking about incident rays or wavefronts. The angle of incidence is supposed to be equal to the angle of what, of reflection, okay? And you know that not all surfaces that are smooth, they are rough surfaces, like my skin, my clothes, the walls, everything that you can see it, okay, it has a rough surface. This rough surface caused the light that reach from a certain source to reflect in all directions, okay, so we can see it, okay? But if we're talking about smooth surface, like a very clean mirror or a very clean glass window, okay, or screened glass like in the malls, you cannot see it unless there is something on it or reflect from it to see it, okay? And the angle of incidence equal the angle of reflection. This called regular reflection, and this called diffuse what, reflection. Now, for example, if I have an incident ray like this, let me draw it for you. Okay, here, this is incident ray. And I have two mirrors, okay, or two surfaces. The first surface, the ray incident it with an angle, as you can see, 20 degrees. I have to draw the normal. It will reflect also with an angle of how much? 20 degrees. As it reached this surface, how much the angle of incidence? Here it's written 50 degrees, but how we know that it's 50 degrees? Who can tell me? Yeah, who can tell me how do we know that this angle is 50 degrees? Who can tell me? Who can send me? By using what? Yes. Thank you. Another answer.
70 minus 20.
20 from the 70.
Yeah.
It's no, it's not like this. Hold on. I have another correct answer. What do we have? We have to know that we have triangles here. We are going to use trigonometry here. Okay, so that means we have a 90 degrees here. Okay, with the normal. So this is 20 degrees. That means that makes this also 20 degrees, 70 degrees. How do I know it's 70? 90 minus 20. Okay, and let's say that the two mirrors that are 70 degrees from each other. So 70 plus 70 is 140, and we have a triangle here, as you can see it. That means this triangle, they have how much the total angle of it, the internal angles, exactly 180. Bravo. So 70 plus 70, it's 140 plus how much? Plus 40 degrees. And we have what? A normal here, okay, 90 degrees. So 90 minus 40, it will be what? 50 what? 50 degrees, okay? And also it will reflect by an angle of what? 50 degrees. Good. I'll explain it again by a different way. Now, if I have two mirrors, and these two mirrors, they have a 90 degrees, okay, angle between them, and there is an incident ray in this way, one, okay, like this, with an angle of theta, for example, that means it will reflect by the same angle, theta A, okay? And we have to know that theta A and theta B, the angle of reflection here, how much the sum of them, yeah? For example, let's say that this is 60. That means also this is what? 60. That makes the angle left here to the mirror is 30. So 30 plus 90, it's 120. 180 minus 120 makes this angle is how much? 30. I'm talking about this larger triangle. Okay, geometry, math, I don't like it. No, you have to like it. Okay, it's simple math. Okay, so that means the reflection here, okay, it will be 30 degrees, and instead it will be 30 degrees, and the reflection, it also will be 30. So how much the addition of theta A and theta B in this situation? How much the addition of these two angles? Exactly, bravo. They have to be equal how much? Another answer, yes, correct. They have to be what? 90. Why they have to be 90 in this situation, but they are not 90 in this situation? Why? Because here the angle is what? Is 70, but here the angle is what? Is 90. Okay, so you have to be careful how you are going to use simple geometry, addition of the triangles, okay, of the angle of triangles to find the answer. Okay, طيب خلينا نكمل هلا هون. Let's try to answer this question. Okay, question number 1. We have an incident ray here, okay, with an angle of incident I 70 degrees, and the two mirrors, as you can see, there is an angle here, external angle of what? 45 degrees. How much is the angle theta? If you please send me, I'll give you 1 minute, okay, to try to answer this question. This ray reflected twice from both mirrors, okay. I want from you to try to send me the answer. Yeah, I will wait 1 minute to send me the answer. You can send it on the chat or on the WhatsApp. Yes, go on. Thank you. شكرا مروان. شكرا محمد. Another answers? Another answer? شكرا. اوبا ها في ناس عم يجاوبوا غلط. شكرا يا إلاف. Okay, شكرا يا أدهم. Adham, are you sure? Check if you please again. Okay, let's try to do it. Okay, يلا. Now we have this angle 70 degrees. This is the angle of incidence. We know that the angle of reflection also equal how much? Equal what? 70 degrees. Okay, now that makes the angle inside here, the small angle here left, because this is normal, 90 degrees minus 70 makes this angle is how much? 20 degrees. So first of all, I equal R equal 70 degrees. That's the first step. Second step, 90 minus 70 equal what? 20 degrees. Okay, this one. Then what we did? We know that we have a whole one straight line angle here. How much the angle here of the straight line? Yes, bravo. How much the angle here of the straight line? Yalla. Another answer. How much the angle here? Exactly. شكرا. Yeah. Yes. شكرا مروان كمان. Okay. No. Muhammad, be careful. Okay. تمام. It's 180. So what we are going to say? 180 minus 45, which makes how much the angle here inside? How much? Exactly, 135. So the angle here is 135 degrees. Okay, so because I know that the angle here is, which is for the big triangle here, it's 135. So how much it will be the angle here? Exactly. So you are going to say 180 minus 135 plus what? Plus 20. Plus 20. And it will be by using calculator how much? 35 or 25? Yes, 25 degrees, exactly. So that makes this small angle how much? 25 degrees. Now, the moment of our answer. Now we know that this is 90 degrees because we have normal, and as you can see, the normal with this surface, okay, it changes its direction as the surface change, the normal change its what? Angle and direction. So here, this is 90 degrees. So 90 degrees minus what? 25 degrees. How much the angle? It will be 65 degrees. And our answer, which is theta, bravo, shukran, shukran. Theta equal what? I equal R equal what? 65 degrees. So this is 65 and this is 65 what? Degrees. Only 3 get correct answer out of how much? Out of 12. A lot of you didn't answer the question. It's simple geometry. Okay, how many times they bring question like this? Only multiple choice question in the last 20 years. They bring it twice. Okay. Tamam? Okay. Not this question, similar to it. Yes. They bring another question similar to it in paper 6. Yes. Yes. Yeah. That was a multiple choice question. Yes. Not this one, similar to it. Yes. Okay. Let's move on. Did you write the answer? Take screenshot. Okay. Let's move on. Now, drawing an image. Now, how we are going to draw an image? Now, you can see me if you were in front of me, okay? You will see me because millions of rays come out from my body, my face, my eyes, my hair, okay, to your eyes, okay? Millions of rays, and that form an image by your brain, okay? So the same thing here. We need at least two rays to draw an image. Now, for example, if this is an object and there is a mirror here, okay, this is the object, and this is the mirror here, okay, and I need to draw at least two rays, okay, random rays. These are two random rays, okay. This is the green one and the red one. As you can see, this green one, it reflects with an angle of incident equal angle of what? Of reflection, and the same one thing for the what? For the red one. Now, as you can see, they go to the eye of the observer, okay, and these rays, they move away from each other, and it seems that they come from the same point. I will draw a straight line where these two lines, okay, they meet. This point, it will be what? Our image. طبعا هذا الحكي حيقعد كثير وقت بالامتحان وبالحصة. أنا بدي أعلمكم هلأ طريقة تانية عشان تحلوها بطريقة كثير سهل, only in a few seconds. You can cheat. شو بدنا يا شباب عشان نعمل هذا الحكي؟ طلعوا بدي أفرجيكم شو بدنا نعمل. هاي وين software? Okay, this one. Okay. شوف شو بدنا نعمل. We're going to bring our ruler and our what? Protractor. Okay, this is ruler. Now what we are going to do? We put our ruler perpendicular to the mirror. What do I mean by perpendicular? 90 degrees to the mirror. How can I check it's 90 degrees to the mirror? I can use my protractor. نجيب البروتراكتور بنحطها. I can check that it's 90 degrees, okay? And I will keep sliding both the image, the ruler and the protractor to make it that 90 degrees until what? Until I reach what? The image here, okay? The object. And I put my ruler at a certain distance, for example, 10, 9, 8, whatever, okay? Then what I will do, I will measure the distance from the object, the center of the object, to the mirror. Let's say this is 1 centimeter, This is 2 centimeter, 3, 4, 5, 6, 6 point what? 3, okay, 6.3 what? Centimeter, okay? On this ruler, it's 6.3, but in your ruler, maybe 2 or 3 centimeter, 3 centimeter, 3 point something centimeter, okay? So what I will do, okay, I will keep the ruler, I will not move it. I will draw a line in what? In the opposite what? Direction, like this, okay? And then I will measure how far it is from the same what? Mirror, the same distance. They have to be like I did here. 1, 2, 3, 4, 5, 6, 6.3. I will do the same thing here. 1, 2, 3, 4, 5, 6, 6 what? 0.3, and this will be what? My image. Okay. Now I didn't do that. Okay. I only draw a what? A straight line like this. So again, I put my ruler from the center of the object, draw a ray like this. Then what I will do, I will draw any random ray, okay? Any random ray with whatever angle you want it, okay, doesn't matter. Okay, like this one, okay, like this one, until it reaches the what? The mirror. Then what I will do, because I know that the angle, the distance it's supposed to be here, the same distance I measured, I cheat, okay? What I will do now, I bring my ruler, okay, put it in some way to draw the extension of this point where it's meet here by what? By my ruler, like this. What is not helping? Okay, hold on. Like this. Okay, and I draw what? The reflected ray. This is the reflected ray, and that's from where the reflected ray comes from. So I draw the incident ray, the reflected ray, and its extension. I draw the incident ray, the reflected ray, and its extension. And these 2 points, they have to meet at the same spot. We're going to answer this question later on. Okay? Tamam? Good? Okay, Marwan. Mashi. Okay. So that's how we are going to answer this question. Okay? Tamam? Okay. Let's move on. Look here. They do the same thing for this example. This is the object, okay, and this is the image. Okay, they draw many rays, 1, 2, 3 rays. They reflect with different angles, but this seems that they come from the same spot, and this spot is what is the image. I need 2 rays, okay, 1, 2. If I draw the third ray, how can we what more accurate? Okay. Now the same thing here. Okay, if there is a candle, and this is my eye, how I can see the candle, the rays come from the candle to reach the mirror, then reflect to my eye. I need at least 2 rays, as you can see here. They put 2 rays, one here, and this from the top, and also from where? From the bottom. They don't do that in the exam. They ask about one spot. For example, draw the top of the flame of the candle where it will be the image of it. I need to do drawing 2 rays, okay? And after drawing 2 rays, I will draw what? The reflection, and I will see that the reflection come from the same spot, okay? But I can cheat. I told you that we can cheat here. خلينا نشوف. Okay. خلينا نمسح هيك شوي. Let's erase this. Okay, no one knows what I'm going to do in the exam, so I'm trying my best to draw it with pencil and draw it accurate. Okay. رأي مروان, he loves this. طب كويس. شوف يا مروان, شو بنعمل؟ بنجيب we bring our ruler and our protractor. Now it's not necessarily a protractor. خلينا على ruler. This ruler is this one. Our ruler. Okay, we put it here, for example, at 10 centimeter. Okay. We measure the distance and we draw it from the top of the candle here, like this. So 1, 2, 3, 4, 5, 6, 7. I'll do the same thing on the other side. Okay. Work smart, not hard. Yes, thank you, Muhammad. 1, 2, 3, 4, 5, 6, 7. Okay, this is the location of my image. Okay, I leave a point. Okay, then what? I'll draw any random ray in any direction that starts from the same image like this. Okay, and this ray I will reflect it in this situation like this. So it can pass through the same candle position, yes, like this here. Huh? Right, of course, it's on the paper, it's much easier than like using computer. Like this. Now, this is the incident ray, this is the reflected ray, this is the incident ray, this is the reflected ray. Both reflected rays, they meet at the same spot here. Okay, that's form what? The image. Okay, tamam? Any question? Is it clear? Let's go to see past paper questions. Yes, now we are going to see past paper questions. Okay, now, have you ever heard about something called Periscope? The Periscope usually use two mirrors or two prisms. Okay, and they use it. This is the Periscope. Actually, it has two open. One you use by the eye, and one that they can stand behind walls or behind anything to see things. Okay, that and they are hiding. Okay, this is a Periscope. The light reflected twice from two mirrors. Okay, they use it in submarine. Yes, Marwan. Okay, they can reflect by two mirrors. Okay, to can see what's above the submarine while the submarine is hiding. Yes, that's called Periscope. They bring a lot of questions about it. Yes. Now your homework, as usually. Okay, the multiple choice questions for next time. Okay, homework questions number 1, 2 until question number 13, page 43. These are your multiple choice questions, your homework. And now let's move on to question 3, page 43. Yalla. Bismillah. Observations of a distant thunderstorm are made. A. During a lightning flash, the average wavelength of the light emitted is this value. This is the wavelength. This is the average wavelength. That means there is above and there is below, but this is the average. Okay. And this light travels at this speed, 3 times 10 power of 8 meters per second. I'm sorry. You're supposed to know this value. You're supposed to know this value. You have to memorize it, the speed of light in vacuum. Calculate the average what? Frequency. What is the formula that I'm going to use? Yes, shukran, Muhammad. Huh? Who can tell us what is the formula that I'm going to use to find the frequency? I have the wavelength and I have the speed. Yes, shukran, bravo, sahih. Who else? What's the formula? The formula is velocity equal frequency multiplied by wavelength. Exactly, shukran, Marwan. So the frequency equal the speed divided by the wavelength, and the speed is 3 times 10 to the power of 8 divided by 5 times 10 to the power of negative 7, and the answer will be 6.0 times 10 to the power of 14 hertz. Good. Tamam. Next, what they say. The interval between lightning flash being seen and thunder being heard is 3.6 seconds. The speed of sound in air is 340 meters per second. It is a big value, yes. That's for yellow or green color, approximately. This is the color between yellow and green. This is the frequency of this color, yes. Okay. Now, what they ask, we have the time between seeing the light and hearing the bang. You know that you see, then you hear, okay? Because sound is not that fast as light. Exactly. Calculate the distance between the thunderstorm and the observer. What's the formula? Are you sure, Salma? Check. What's the formula? Distance equal what? Y8 seconds. Okay, Muhammad, check your answer. What do they ask? They ask about the distance. We know that distance equal exactly speed times time. Yes, not speed divided by time. Speed times time, because we know that speed, okay, equal distance over time. So we do cross multiplication. So distance equals speed times time. Shall we divide by 2 here? Shall we divide by 2 over 2? Because there is an echo here.
No.
They didn't mention echo, so exactly we are not going to write anything here. So 340 multiplied by 3.6, and by using calculator, it will be how much? 340 times 3.6, 1224, 122 for what? Meters. This is how far is what is the thunderstorm. Double I. Explain why the speed of light does not taken in account, okay, in the calculation. Yeah, for example, if you are measuring the between two things, the time difference between two things, and you have to know how far they start from, that means you have to know the distance for this one and the distance for that one. Then you subtract, like the question that I seen a couple of days ago. They are about earthquake and tsunami. Okay, actually, here we are not going to talk about the time for light. Why? Because this distance, the 1,124 meters, is nothing compared to speed of light. We neglect, okay? Light is too fast due to this small distance. So because light is much fast, that means the time of it is negligible. So we didn't subtract the time of the light traveling, okay? Like what we did last time when we talk about speed and of water waves to tsunami and speed of the earthquake. I didn't answer this question here. I answered on another group. Take a screenshot. Is it clear? Okay, let's move on. Question number 4. The figure below shows a part of electromagnetic spectrum. Okay, we have gamma rays, X-rays, UV, visible light, infrared, radio waves. They didn't mention what microwave here, right? Okay, so name one type of radiation. Name one type of radiation that has, name like state, that has a higher frequency than ultraviolet. This is ultraviolet. Which one has a higher frequency than ultraviolet? We are going to the right or to the left in this table? Oh, tell me, which one has a higher frequency? Not correct, ya Muhammad. Check. No. Higher frequency. Now, whenever we go to radio waves, the radio waves has least frequency. So that means exactly the answer, it will be X-rays or what? Or gamma rays. You can write one of the answers. You can write X-rays, you can write gamma rays. This is a Greek letter, gamma rays. Okay, or you can write gamma, no problem. طيب. Another question. They ask for a longer wavelength than visible light. I just say that whenever we have to go to the side of radio waves, the frequency decreases, but the wavelength increases. Exactly. So that means shukran ya Muhammad now. Yes. So longer wavelength than visible light, you can say infrared, or what you can say radio waves. Yes, bravo. صح. Or you can say what? Radio waves. What about microwaves? Of course you can mention microwave, but they didn't mention it. Right. شكرا يا عبد الرحمن. شكرا يا محمد. Okay. Next. What they ask. Some gamma rays emitted from radioactive source has a speed of 3 times 10 to the power of 8 meters per second. That's the speed of all electromagnetic spectrum in vacuum, okay? Speed of light, yes. And wavelength, 1 times 10 to the power of negative 12 meter. This is the wavelength. So that we have the speed, we have the wavelength here. Calculate the frequency. So we know that V equal F lambda. So that means frequency equal speed divided by wavelength. And it's 3 times 10 to the power of 8 divided by shukran ya Muhammad, صح, correct answer, divided by 1 times 10 to the power of negative 12, and the answer will be 3.0 times 10 to the power of 20 hertz. It's a huge value because it's gamma rays. Gamma rays has a highest frequency. So by knowing how to answer this value, and you can see this value, see it's a huge number, you can remember to get correct answer for these parts. Okay. State the approximate speed of infrared in air. Now, who can tell me how much the speed of infrared in air? I just mentioned the answer. Who can tell me what the speed of infrared in air? Yes, bravo, shukran, صح. Another answer? Excellent. It's 300 million meters per second, or you can say 3.0 times the power of 8 meters per second. Shukran ya Muhammad. Shukran. Okay. تمام. أنا آسف بس شوي تعبان اليوم. Okay. This is a core question. Okay, but I like this question because sometimes they bring ideas as multiple choice or as paper 6, similar to this one. What they ask. The figure below shows a ray of light, AB, this is AB, okay, striking a plane mirror at an angle of incident of how much? 40 degrees. This is the normal. This is the the angle of incidence. Good? Okay, so we have a mirror, we have incident ray, and we have the normal. This is the angle, it's 40 degrees. They mention it, okay? State. That means you know the answer. State the value of the angle of reflection of this ray. Yes, huh? Bravo, Muhammad, huh? Another answer, yalla. Excellent. Bravo, huh? A third answer. Shukran ya Marwan. Yes, another answer. How much the angle of reflection it will be? Excellent, ya Shabab Sabaya. It's what? 40 degrees. Why 40 degrees? It will reflect in this direction. Okay, so the angle of incidence is 40, the angle of reflection is 40. It's obvious. Okay, next. In the figure below, this one, it's the same figure, but they tilt it, okay? The mirror has been rotated 10 degrees. This mirror, instead of being like this, they change its angle, something like this, okay? As shown by what? By 10 degrees. For the previous figure, use straight edge ruler, okay, to draw the reflected ray. Now, what do we have to say here? And state the value of the angle between the reflected ray and the line BC. Okay, through how many degrees does the reflected ray has been rotated when the rotation of how much? 10 degrees. Look here. To answer this question, actually, okay, I have 3 parts. What I will do, I will use my protractor, and my ruler. So let's use my protractor first. This is the protractor. Where is it? Okay, I have to rotate it and put what? Put it like this. Okay, exactly. And I have to measure this angle, the new angle, because they rotated by 10 degrees. That means this is the new normal. This is the new normal. Okay, by green line. that means this angle here, it's 10 degrees. Okay. Tamam. So what they ask? They ask to draw the reflected ray. So how much the angle of incidence here? I start from 90. Okay. What? 10, 20, 30, 40, 50 degrees. I'll draw from the other side. Okay. 10, 20, 30, 40, 50 degrees. I will label this point. Then what? I will draw what? A straight line through this angle. Okay. So this is 40, 60 degrees. I will draw what? I will draw my reflected ray like this. So this is the reflected ray. On the same previous figure, use a straight edge to draw the reflected ray. I just draw it. Again, I bring my protractor, put it here. Okay. Draw the new incident. Okay, the new normal. I measure from the normal how much degrees here. It's 10, 20, 30, 40, 50, and 60. Okay. Then I'll draw it from the other side, from the normal. 10, 20, 30, 40, 50. Okay. I'm sorry, 50, 50, not 60. Okay. Then I'll draw what? The reflected ray like this from the same point. Okay. I can erase this. Yes, of course. So I erase all this. Okay. This is my reflected ray. Tamam. What they ask also. On the same previous figure, use a straight edge to draw the reflected ray. I draw it. Okay. State the value of the angle between the reflected ray and the line BC. Who can tell me how much is this angle now? The whole of this angle here to the line BC. How much is this angle? No, check again. How much is this angle? How much is this angle here? Yes. It's not. Okay. Now, this angle is the angle of incidence. It increases by 10. It becomes 50. And this is the angle of reflection. It becomes also what? 50. So I'm talking about 50 plus how much? Exactly. So bravo. شكرا يا أدهم. شكرا يا مروان. شكرا يا مين كمان بعت الجواب الصح. في ناس كثير بعتوا الجواب الصح. مروان أدهم. Okay. عبد الرحمن. Yes, it's 60 what? Degrees. 60 what? Degrees. Okay. Then what they ask here? Through how many degrees does the reflected ray rotate when the mirror rotates by 10 degrees? Now look here, ya shabab. Okay, in the previous part here, okay, that's part A, it was angle of incidence 40, angle of reflection how much? It was also what? 40, right? So the whole thing, 40 plus 40 is 80. Now 50 plus 50 is 100. So this angle, now it's supposed to be in this direction, something like this. It changed to this new position. How much is this angle? How much is the new position? When I bring my protractor, okay, and I put it on the, where here exactly, I can see that the angle was 40 when the normal was here. So the angle of reflection was what? 40, 10, 20, 30, 40 here. Okay. But now it changes by how much? It changes by what? From 50 here exactly. Okay. To what? To 30 here. So how much is the angle here? Exactly 20 degrees. Yes, 20 degrees. So the answer here is 20 degrees. By how much? The rotation was, it is twice 10 degrees. It's what? 20 degrees. Good. Any question? This is core. Yes. Tamam. So the whole this angle here was, okay. The whole this angle was 40. the reflected was 40 in the initial position, so it was in this position, for example. Then it's the mirror rotates by 10 degrees, so this is the new normal, the green line. The angle of incidence becomes what, 50. The angle of reflection becomes 50, so the whole thing is 100 exactly. So 80, which is 40 plus 40, and 150 minus 50, 100 minus 80, the angle is what here? It's 20 degrees. Okay. So what I'm going to draw only this one, and I'll write here 60 degrees, and I'll say 20 what degrees. That's the answer. Okay, good. So here 60 degrees, and I'll draw it. Don't forget to draw it. Okay, and here how much? 20 degrees. Why 20 degrees? I will write here the answer again. So 40 plus 40, the angle of incidence and the angle of reflection was 80. Then it increased by 10 degrees. So 50 plus 50 equal 100. From both of these answers, we said 100 minus 80, and the answer is what? 20 degrees. Okay? Tamam? Okay. Good. Now, if I have a mirror, a plane mirror in front of me, okay, and I'm looking to myself, whenever I'm getting closer to the mirror, my image gets closer. Whenever I'm getting far from the mirror, my image gets far from the mirror also. And my image, it will not be that big or that small compared to the what? To the image. So if I'm going to draw an image and I'm going to describe the image of, okay, of any obstacle, any object here, okay, what are the characteristics of my image? What are the description of my image in the plane mirror? Description of image formed by plane mirror. Yes. Yes, shukran, Muhammad. One of the answers is not inverted upside down. I'm not going to see myself inverted upside down. I'm going to see myself inverted right and left. That's called laterally inverted or right-left inverted. Laterally inverted. Okay, let me write here. Right, left. Right, left inverted. Okay, what else? Can I see my image bigger or smaller? Or same size? Yes, same size. Bravo. Same size. Okay, what else? Can I see my distance to the mirror, the image of the mirror? Okay, and the object of the mirror, same distance or different distance? Exactly. Same distance to the mirror as the object.
Sir.
Yes.
Then why in the car mirror they say the objects here are closer?
It's not a plane mirror.
Then why don't they use a plane mirror?
It's curved. Why they use curve? You tell me.
Maybe because it can see more.
Exactly. The curved mirror can cover more area here. This is called convex. Convex mirror. And this convex mirror, it can see more image. And the one that we use it to see your face bigger, it's called concave. Okay. So one cover more area but smaller. One cover less area but bigger. Okay. See more but not accurate. Yes, exactly. So what are the characteristics of any image by plane mirror? Same size, Same distance to the mirror as the object, laterally inverted. And the fourth thing, which is very important, students forget to write it down, it's virtual image. What do I mean by virtual image?
It's not real.
What do I mean by not real? Bravo.
It's
It cannot be formed on a screen, on a paper. And if I bring a mirror, I can't do a reflection of my face on a paper. Except I'm talking about plane mirror, okay? If curved mirror, yes, I can. But straight line mirror, no, I can't. So that's why they call virtual image, because the rays do not meet. The rays, these rays do not meet, okay? It seems that they come from the same spot. Okay? Tamam? So why I'm writing a virtual image? Okay, because the rays, they don't meet. Rays don't meet to form an image. Okay, that's why we call it what? Not real image. Good. So let's return back to our question here. Last part, C. Okay. Okay. Do you want me to return back? Okay. Write this down if you please, or take a screenshot. These are the characteristics of the image by a plane mirror, or the description of it. Okay. Take screenshot. Tamam. Okay. Now let's go back to our question. Part C. What they say? An object of height 2 centimeter is placed 5 centimeter in front of a plane mirror. So this is the height, and this is the distance from the what? From a plane mirror. Okay. This is the plane mirror, for example. Okay, and it's 5 centimeter away, and it's 2 centimeter high. Okay, its image, what will happen to it? Exactly, its image, it will be formed somewhere here. That's the image. Okay, it will be the same height, same distance to the mirror. Bravo, صح? So an object of height 2 centimeter is placed 5 centimeter in front of a plane mirror. State the height of the image. State, that means you know the answer. How much is the height of the image? How much is the height of the image? Yes, شكرا يا محمد. شكرا يا شباب. Bravo. شكرا يا صبايا. 2 centimeters. Find the distance between the object and the mirror. How far is the distance between the object and the mirror? If we know that the distance here is how much? 5 centimeters. So the whole distance, it will be how much? Exactly 5 multiplied by 2, which is how much? Exactly 10 centimeters. شكرا عبد الرحمن. شكرا يا محمد. شكرا لكل الشباب والصبايا اللي عم بيجاوبوا. Good. Take screenshot and write these answers if you please. Okay. Next. Also core paper, core question, but they bring it as multiple choice question, the ideas of it. What they ask: a student looks into a vertical mirror. Can I go back? Yes, of course I can go back. Yeah. Okay. Question number 6, page 45. A student looks into a vertical mirror to see the reflection of a burning candle. Okay, and the figure below shows one ray of light being reflected by the mirror. Okay, on the ray in the previous figure, mark arrows to indicate the direction of the travel of the light. In which direction does the light travel? From the candle to the eye, or from the eye to the candle? Yes, who can tell me? In which direction? From the candle to the eye, exactly. Shukran ya Muhammad. Shukran ya Salma. So from the flame to what? To the eye. Yes, shukran ya Marwan. Shukran. Yes. Good. So in this direction, I need to put an arrow. That's it. Whenever they draw a ray, I have to put an arrow to represent the direction of it. On the same previous figure, clearly mark the position of the image of the candle in the flame. Okay, how can I do that? Yes, yes, bravo. I will use my ruler. Huh? So what are we going to do? I will extend this line by ruler like this. Then I'll bring my ruler and put it perpendicular to the mirror and what? Draw another incident ray, which is what? 90 degrees to the, okay, to the, with a normal, perpendicular to the surface. And where these two rays or two lines meet, it will be what? My image, huh? Let me draw it more accurately by using what? The this application. Okay, look here. Okay, I'll use my ruler. I put it vertical, okay, to the mirror, perpendicular to the mirror. Then what? I will draw a line like this, 90 degrees to the surface, yes. And also, I will continue this ray that come out from the eye, okay, until these two rays, they meet. Okay. Yes, where these 2 points meet is my image, this point. I will label it by using letter I or any letter that they ask us to use. Can I do it with a different ray? No problem, huh? Okay, huh? Let's us do with another direction. Okay. For example, I can do it with this one like this, but I have to measure how much is the distance from here to here, and from here to here they have to be equal, right? Okay, then what? I will use my ruler to indicate the point that exactly, yes. And I will draw the reflected ray and its extension. Yes, these, they have to meet at the same spot. Now it's not necessary to draw the red line that I just drew it, okay? It's not necessary. Good? Any question here? Okay, let's move on. Part C. The candle moves further from the mirror. They move this candle to the left, okay, further from the mirror. What they say? State. State means that you know the answer. State. If any, what will happen to the position of the image, to the size of the image? What happened to the position? Move to the right, moves further to the right, exactly. Moves further to the right, further to the right. Okay, what happened to the size of the image? Yes? Who can tell what happened to the size? Bravo. What happened to the size of the image? Remains the same. It doesn't change. Okay, it looks like it gets smaller, but actually it's not. Okay, it will have the same size. Okay, good. Write down the answer here. I'll take a screenshot. Now, question number 7. I want from you to try to do it and send me the answer. Okay, yes, I'll wait for 2-3 minutes. Okay, if you have the paper, if you print it out, if you please send me the answer now. Okay, yeah, yes, send me the answer on the WhatsApp. Yes. I want from you to try to do it by your ruler and your pencil. Yes. If you want to do it on your tab, no problem. Or your mobile, and send me the answer. Shukran. Oh no, it's not like this at all. I will not mention the name. Okay, it's not like this. Here in this question, we draw it by the application, like this. Okay, by using a straight ruler. Okay, with measurement, or you can do it whatever you want. Okay, then yes, question 7. Another answer? Another answer. Good, good, but continue it. Continue it if you please, Marwan. Continue it in both sides. Bravo, Marwan. Marwan, try to do it as accurate as possible. Another answer. طيب خلاص يلا نجرب. Okay, look what we're going to do, شباب. We know that the light will reflect in this direction approximately, something like this. Okay, now what we will do before we draw these, because we don't know how much is the angle of incidence here, we have to use the protractor. I can cheat, I told you. Okay, I can bring my ruler and I can put it in this way, vertical, 90 degrees, perpendicular to the surface, to the mirror. Okay, and what I will put it on a certain distance, for example 10 cm or whatever. Okay, now don't forget the measurements here is not the same as measurements for you. Okay, now what I will do, I'll draw a straight line that pass, okay, by pencil, and I need to erase it. Okay, something like this. I'll measure the distance, how far it is from where? Yes, how far it is from the mirror. Okay, let's say this is 1, 2, okay, 3, 4, 5, 6, okay, 7.2. Okay, so what I will do, I'll measure the same distance on the other side. I'll say, okay, 1, 2, 3, 4, 5, 6, 7, 7.2. Okay, where's my image? Okay, tamam. So this is my image. It will be somewhere here. 1, 2, 3, 4, 5, 6, 7, 7.2. Okay, now from this point where I put, okay, what I will do here, exactly, the real distance is 3.1 centimeters. Shukran, Marwan. What I will do, I bring my ruler and try to draw lines from this point to where the exactly, not necessarily, you have different printers, that's why you have different values. Okay, so I'll draw a line like this. Okay, so that's how the ray reflected in this direction. It seems that come out from somewhere behind. Then I will do that again on the second ray. As you can see here, okay, this is the second ray. This is where the ray reflected, and this is where the ray comes from. And you can see that this point, the rays, wherever you draw it, okay, is my image. I will label it with a point what? I. Okay, so here it's my image I. Okay, tamam. Good. Draw this if you please. Okay. Next. So on the figure, continue the path of the two rays after they reach the mirror. Hence, locate the image of the object or label it with I. I told you we cheat. If you want to make sure your drawing is correct, what you are going to do, you are going to use the long method. What's the long method? I have to bring my protractor. I have to wait. I have to put it twice on both mirrors, like one here. I have to measure how much the angle of incident, 1, 2, 10, 20, 30, 40, 50. I'll make another angle 50 here. Okay. Then what? I'll draw the incident ray. Oh, sorry, the reflected ray. Okay. I'll repeat the same thing on the second point, second ray here. The angle is from the normal, from the 90, 10, 20, 30, 40, 50, 60. Okay, I'll make the angle here also 60. Okay, from the normal. Okay, then what? Oh, I'm sorry. Then what? I will draw the reflected ray. Okay, these two rays, I will use my ruler to extend both of them. Okay, I'll draw the first one. I will draw what for the second one. It's very hard by using these softwares. Okay, I'll draw these two rays, and whenever these two rays meet, it's what? It's my image. Okay, good. Okay. Now, describe the nature of the image. What is the nature of the image I? We have, I told you 4 descriptions before. What are the nature of the image formed by any plane
Virtual
mirror?
image.
Virtual, bravo. Virtual. What else?
Inverted, laterally inverted.
Okay, inverted. You can write inverted here because the mirror is above you, inverted.
And there is a distance between the object and the mirror.
Exactly, same distance to the mirror.
And same size.
Same size, it's a dot, okay? But you can say same size, okay? Same distance to the mirror as the object. To the mirror as the object. Tamam. These are 1, 2, 3, and you can write 4 same size. Okay. Any question here? Is it clear?